Today we will start talking about Chapter 8. We will do 3 sections in Chapter 8. 8.1 will be graphs of sine and cosine functions. 8.2 will be the graphs of other 4 trigonometric functions. And finally, we will talk about inverse trigonometric functions in 8.3. Let's start with the graphs of sine and cosine today. So remember, sine when at 0 is equal to 0. Sine at pi over 2 or 90 degree is 1. Sine of pi is equal to -1. Sine of 3 pi over 2 and sine of pi is equal to 0 as well. So sorry. Sine of 3 pi over 2 is equal to -1, and sine of 2 pi, we are now back to 0 one more time. This entire list of values gives us one full period of a sine function. So if you just try to use these values, for example, at 0 I have 0, at pi over 2 I have the value 1, at pi I have the value 0, at 3 pi over 2 I have the value -1, at 2 pi I have 0, and then connect these points with nice carved lines, we get the function sine's graph for one full period. Today's class we will dedicate to learn how to draw any sine function with horizontal or vertical translations, reflections, vertical and horizontal stretches, how to realize those graphs, or given the graphs, how to realize the function. Because we know the domain of sine function or the input for sine function can be any real number, we can actually extend the graph that looks like this nice periodic natured graph. So for example, if we want to know the graph of 2 times sine x, then the amplitude of the sine function becomes doubled. Remember, in the original graph, the values of sine was bounded between -1 and +1. So if I have 2 times sine x, those two values are now bounded between -2 and +2. But the rest of the nature of the graph doesn't change as much. If I have a horizontal shift, for example, if you look at sine x minus pi over 3, then this graph, the original graph, which is in gray color here, will be shifted pi over 3 units to the right, which is the blue colored graph. I can have a vertical shift, so this time the +3 is a shift upwards by 3 units. So whatever we were having on the x-axis, now it is going to occur at y equal to 3, because the graph will be shifted 3 units upwards. Our intention is to combine all these factors all together and learn the graphs of general sine function. So what I will do, I will go ahead and skip to the point where we have a general sine function given to us and discuss how to draw the graph of this function. So say we are given with the function y equal to a times sine bx minus c, where a, b, c are real constants. Then the amplitude of the sine function is given by absolute value of a. Amplitude is the largest value which essentially determines the range of the graph, the minimum height the function can attain to the maximum height the function can attain. The period of this sine function, remember the original period of a sine function is 2 pi units. The period of this transformed function is given by 2 pi, the original period, by the multiplier b. The phase shift is given by the constant c over b. One other easier way to remember the phase shift is thinking about this input bx minus c, setting it equal to 0, and solving for the variable x. So that is c over b. So original sine function, the way it will behave in this transformed form of the sine function, it is going to behave the same way between the values of c over b and c over b plus the period 2 pi over b. that will be one period for this transform function, as if we are transforming the period 0 to 2 pi according to the transformed sine function given here. If you have a constant added with this function outside of the input, so that's plus d here, then I know that depending on the sign of d, so to say d being positive, I will do a shift upwards by d units, and d being negative, I will do a shift downwards by d units. If the constant multiplier a is less than 0, and remember a is multiplied with the functional value, with the output, and if it is less than 0, then we do a reflection along the x-axis. If b, which is the constant multiplier to your input variable, if that is less than 0, then we do a reflection along y-axis. So what we would like to do now, start with examples and make this process become a little easier to understand by actually working out this and drawing the graph. So I look at my function given here is y equal to 12 sine 2x, and it is asking me to find the period first, then use 5 key points. So I want to remind you the key points for a general sine function. If the function were to be y equal to sine x, then what you would do. Remember, we use the value 0, pi over 2, pi, 3 pi over 2, and 2 pi as the general key points for a sine function. We're going to adapt that same technique, but now with possible phase shifts and amplitude change. So first and foremost, our function is of the form 12 sine 2x. Think about the general form that we have talked about. It is y equal to a times sine of bx minus c. So clearly there is no c in this situation, or you can go ahead and say that a is equal to 12 units, b is equal to 2 units, and c is equal to 0. So let's first find out the period of this sine function. The period of this sine function is going to be 2 pi over b, and b is 2, so that's pi units. So I'm going to answer my first question, pi here. Then in order to find the key points, what I do, I divide the period, which is pi, by 4, then start with the phase shift value. So how much is the phase shift in this function? If you remember the formula for the phase shift is given by c over b, that our c is equal to 0, b is equal to 2, so that is 0. So we start at 0. Then I keep adding this value that I got by dividing the period by the number 4. So 0, pi over 4. I add pi over 4 one more time. I get 2 pi over 4, but remember that can be simplified as pi over 2. Add pi over 4 one more time, you get 3 pi over 4. Add one more time, you get 2 pi over 4. That should be 4 pi over 4, I'm so sorry, and that is equal to pi, and that's the end of the period. So what I do, I write down my key points as 0, pi over 4, pi over 2, 3 pi over 4, and pi. And I tell myself constantly this 0 acts as the original sine function acts at 0. Pi over 4 acts as original function's pi over 2. Pi over 2 in this new function acts as the original function's pi. 3 pi over 4 acts as the original function's 3 pi over 2. And pi acts as the original function's 2 pi. Then it is a little easier for us to draw the graph of this function. Remember, since a is 12, I'm going to go ahead and say the amplitude in this situation, the highest possible value of the sine function, is absolute value of a, which is absolute value of 12, and that is 12 units. So how do I draw the graph? I start with the Cartesian coordinate system. On the x-axis, I start with the original point 0, then the key points pi over 4, then the key point pi over 2, 3 pi over 4, and finally we do pi. The amplitude being 12, I will say 12 positive, and I will say 12 on the negative direction as well. So let me draw it one more time. So say this is negative 12. Then remember the original sine function. It starts at 0 at 0. At pi over 2 it becomes 1. Instead this time my graph will start at 0, become 12, come back to 0, goes to negative 12 at 3 pi over 4, and becomes 0 at pi. And that's one full period for this transformed function. And as you can imagine, I can go ahead and carry on the same periodic nature of the graph as long as I want to. And that completes the first problem for us. And this is a simple technique that we're going to adopt and follow in every single function where we're drawing the graph. Now we are interested in drawing the graph of the cosine function. So the cosine function, it is pretty much the exact same setup, except the original graph is a little different. So how different the original graph is going to look like? So think about cosine at 0 becomes 0. Cosine at pi over 2, cosine at 0, I'm so sorry, becomes 1. Pi over 2, it is 0. Cosine at pi, it is negative 1. Cosine at 3 pi over 2, it is back to 0. And at cosine 2 pi, it is 1. And that is one full period. So if you want to see the graph of cosine for this first original period, then you will do 1 to 0 to negative 1 to 0 to 1. That is the graph of cosine, where these key points are 0 pi over 2, pi, 3 pi over 2, and 2 pi. So let's go ahead and work out this problem. This time the function is y equal to 10 cosine 4x. It's pretty similar. We can first talk about the amplitude of this function. So the amplitude of this function is going to be absolute value of a, just like sine. So this is absolute value of 10, so 10 units. So instead of 1 and negative 1, it should be 10 and negative 10. Period for this function. Remember the b value in this problem. So we know that a is 10. Actually, let me go ahead and write it somewhere else because I need to fill in the blank for the period. A is 10. B is 4. And C is 0. So the period is going to be 2 pi over 4. And that's pi over 2. So whatever happens for the original cosine function between 0 and 2 pi, the same thing is going to happen between 0 and pi over 2 for our transform function. What is the phase shift? Well, the phase shift for this function is going to be c over b, which is the value of c being 0. Doesn't matter what b is, it's still 0. So we start at 0. So we need to understand our basic key points. Remember the process. You start with the period and you divide it by 4. So you get pi over 8. So I'm going to start writing the key points. Starts at 0 because phase shift is 0. Then I keep adding this pi over 8 value. So the next one is pi over 8. The next one is 2 pi over 8, which you can simplify and make it pi over 4. The next one is 3 pi over 8. And the final one is 4 pi over 8, and simplify that, and that's pi over 2. And remember, your period ends at pi over 2. So we are pretty set. We can now draw the graph of the cosine function. I have my key points at 0, at pi over 4, pi over 2, actually the pi over 8 and then pi over 4 in this problem. And then I have 3 pi over 8. And finally we have pi over 2. Amplitude being 10 units, it will be positive 10 and negative 10. And then you repeat the graph of the cosine function. You start at 1, go to 0, then you go to negative 1, come back to 0, and come back to negative 10. And that answers your question. And as usual, you can just keep repeating this nature of the function, this periodic nature, as long as you want. And that's a graph of the cosine function. Our next example is a little more intricate. So again, we're going to find the amplitude. So A being 5. And what I do, I distribute this 2 in order to make this look like our original setup. So I basically get y equal to 5 cosine of 2x minus pi over 3 when you multiply the 2. So your b is equal to 2 and your c is pi over 3 units. Now with this setup, we're going to find out the amplitude, the period, the phase shift, and hence the key points, and draw the graph of this cosine function. So clearly the amplitude is absolute value of A, so that's 5 units, so it's between -5 and 5. Period, original period is 2 pi, I divide by B, so that is the period of this sine function, this cosine function, and that is going to be pi. Phase shift is going to be the formula C over B, so I get C being pi over 3 and B being 2, it is equal to pi over 6. Okay, so now we start working on this problem, and we say the phase shift is pi over 6, so we start at pi over 6 instead of starting at 0. So we find our key points. Remember, to find the key points, we're dividing the period, which is pi this time, by 4. So every time we're adding 4. So the key points are x1 equal to, remember you start at pi over 6. x2 equal to pi over 6 plus pi over 4. When I find the common denominator, I'm going to get 2 pi plus 3 pi over 12. So that's 5 pi over 12. x3 is going to be 5 pi over 12 plus pi over 4. Again, you find the common denominator. So you get 5 pi plus 3 pi over 12. That's 8 pi over 12. And one can simplify that as dividing by 4 on top and bottom. 2 pi over 3. x4 is going to be, I can start with 8 pi over 12, that will be easier to add, plus pi over 4, which, when found the common denominator, is 8 pi plus 3 pi over 12. That's 11 pi over 12. And I need one more, and that's going to be the fifth key point, x5, which is 11 pi over 12 plus pi over 4. So that's going to be 11 plus 3. Pi plus 3 pi over 12, and that is equal to 14 pi over 12. I can simplify by dividing top and bottom by 2, so I get 7 pi over 6. Now remember, this makes sense because you started at pi over 6 and the period was pi, so you will end at pi over 6 plus pi. And again, you can find the common denominator for the second sum, and you get 7 pi over 6. And then we know what is next is just drawing the graph with my key points and maintaining the nature of the cosine function. The amplitude this time is 5, so it's -5 and 5. And then I need to use the key points for this problem starting at pi over 6, where the phase shift starts. So I first say this is my starting point at pi over 6. Remember, the second key point was 5 pi over 12, so that should be somewhere here. Then I had 2 pi over 3 as the third key point. Then we have 11 pi over 12 as the fourth key point, and finally we have 7 pi over 6 as the full period. So at this point you are the highest value 5, then you come back to 0 at the next key point, and the next key point you're the lowest value -5, then you go back on the next key point at 0, and finally you end at the highest peak, which is 5. And if you want to, you can just go ahead and show me the nature of the periodicity of this graph, and that will answer your question in full. Let's see what else can we do. So this one is again in terms of sine, but the same construction. So let's start talking about this problem. Amplitude is my first thing, and if you want to, you can go ahead and write the ABC values. Your A is -10, so amplitude is absolute value of -10, which is 10. So between -10 and 10. Your B is 3 and your C is 9. So period is the next thing that we will find out. Period of this sine function is 2 pi over 3 units. Phase shift is C over B, so that's 9 over 3, and that's 3 units. So instead of starting at 0, we start at 3 this time. Okay, so in order to find the key points, we are going to divide the period 2 pi over 3 by 4, and that becomes 2 pi over 12. You can simplify that as pi over 6. So period is 2 pi over 3. Phase shift is 3, and we find the key points. X1, of course, I start at 3. X2 is 3 plus pi over 6. Now I can find the common denominator and write it as 18 plus pi over 6. The third key point is one more pi over 6 added, so that's 18 plus pi over 6 plus pi over 6, which is going to make it 18 plus 2 pi over 6. I can divide both top and bottom by 2 and get 9 plus pi over 3. Simplified, it just looks better. But x4, I will use 18 plus 2 pi over 6 before I have simplified the value, just because it is easier to add. And that becomes 18 plus 3 pi over 6. So now you can divide top and bottom by 3, and you get 6 plus pi over 2. Finally, the last key point, x5, is going to be 18 plus 3 pi over 6 plus pi over 6, and that 18 plus 4 pi over 6. I can divide both top and bottom by 2, and I get that is equal to 9 plus 2 pi over 3. Now let's make sure that we have done our calculations right. Remember, we started at the phase shift. The phase shift was 2 pi over 3, 3, and then we are going to end at the phase shift plus the period. So you started at 3, and this is your entire period. So what do you get? When I find the common denominator, it is 3. 3 times 3 is 9, so I get 9 plus 2 pi over 3. So my calculations are right. Because I started at 3, I ended at 9 plus 2 pi over 3. Rest is pretty simple, drawing the graph. Remember, this was the sine function. I just have to write down all my key observations here. I started at 3. The next point that we did, the next point is 18 plus pi over 6. So say this one, 18 plus pi over 6. The next key observation was 9 plus pi over 3. And then we had 6 plus pi over 2. And finally, the end of the period was 9 plus 2 pi over 3. There is one other observation here. This function has a negative multiplier to the output, so you're changing the y values, so that will be a reflection along the x-axis. And the amplitude being 10, I'm going to get the negative 10 as the lowest point and positive 10 as the highest point. So at the beginning, and I'm beginning at 3 this time, sine is still 0. But then instead of going up, this is the natural way of sine, but instead of going up, I should now come down because of the reflection and become negative 10 at the first tip. Then I should go up, become 0, up again, become highest at 10, and come down once more to become 0. And that's the full period of this transform sine function. As usual, I can do this just to let our audience know that this is a periodic function. It keeps this periodicity over the entire domain of the real numbers. So we have done this problem already once. What we will do now, we will change this negative 6, we'll keep it as pi over 6, but this 2, we're going to just consider nothing there. And I'm doing it because we have already done the other side of the problem. So what about this one? So you have 5 cosine x minus pi over 6. So this time a is equal to 5, b is equal to 1 because the multiplier of x is 1, and c is equal to pi over 6. Okay? So amplitude is 5, period, it's not going to change because b is 1, so it's still 2 pi over 1, so 2 pi. Phase shift is c over b, so that value will be a little different. It is going to be pi over 6, that's your c, over 1, that's b, so pi over 6. So instead I start at pi over 6. Key observations, so take your period, divide by 4, and you get pi over 2. So every time you add pi over 2 to get your key points. x1 starts at pi over 6, then I keep adding pi over 2. So x2 will be pi over 2 plus pi over 6 in the common denominator. So that will make it 3 pi plus pi over 6. That's 4 pi over 6, which is 2 pi over 3. The third key point is 4 pi over 6 plus pi over 6. So I get 5 pi over 6. Fourth key point is 5 pi over 6 plus pi over 6 one more time. And that becomes pi, because it is 6 pi over 6. And finally, the period ends at the fifth key point, which is 6 pi over 6 plus pi over 6, and that makes it 7 pi over 6. So let's check whether this work is right. Remember, this should start at the phase shift of pi over 6, and then it should go to the phase shift plus the period, which is 2 pi. Again, if I find the common denominator, I should get pi over 6 plus 6 pi over 6, which is indeed what we have found out. Pi over 6 to 7 pi over 6. So let's draw this diagram. It's a cosine function. The amplitude is 5 units, so the highest value on the graph is 5. The lowest value on the graph is -5. It starts at pi over 6. Then it goes to the next key observation, which is 2 pi over 3. Then it does 5 pi over 6. Then it does pi, and finally it ends at 7 pi over 6. So I start at the highest point for cosine, then go to 0, go to the lowest point, go to 0, go to the highest point for one full period. Periodicity completes the quest of finding the graph of this cosine function. So if your function was 5 times cosine x minus pi over 6, this is how you will draw the graph of the function. The last question in this section that we will try to encounter is, given the graph, how to find out the equation of this function. Now, apparently what I can see, this function looks like a cosine function. If you start at this point, which is the highest value, and if you count these digits, then you will find out this is 1.2. So let me write down 1.2. This is 1.4, 1.6. This one is 1.8. So basically, what is my point? The highest value on this cosine function is at 1.8. And the lowest value on this cosine function is at -2. So I say highest is 1.8, lowest is -2. So that means the center line is no longer at 0. If the center line was at 0, then the highest point should have been the same but positive, and the lowest point would have been having the same value but negative. So it is no longer 0. How do I know what will be the center line? So what I do, I find the total difference or range for this graph. So the range of this graph is 1.8 minus -2, highest minus lowest, which is 3.8. So 1/2 of the range should be 3.8 all over 2, and that is 1.9. What does that tell me? That tells me that this function that we are trying to understand would have the center line at -0.1. I will tell you why that should be at -0.1. If this is the center line, -0.1, and you add 1/2 of the range, then you should get 1.8, which is the highest point of my cosine function. If you start at the center line at -0.1 and you subtract 1.9, half of the range, you should get -2. So that tells me the center line should be -0.1, which tells me you can think of your original cosine function and shift it down by 0.1 units. So keep that in mind. Just keep in mind that this is a shift down by 0.1 units. Now we will think about the period of this function. And since I am starting and thinking this one as a cosine function and I have the highest value at 0, remember the highest value is at 0, there is no phase shift, or in other words, the phase shift is 0, implies C must be 0. How about the period? Well, you start at 0 and there you have the highest value. The next highest value happens at this point, and this is 1.8. So that tells me that the period is equal to 1.8 units. If the period is 1.8 units, then the formula tells me 2 pi over whatever the b is should be 1.8. So what is the b? We'll solve this equation for b, and b becomes 2 pi over 1.8, which when simplified gives you pi over 0.9. I can use this one as my b, or I can simply write this thing as 9 pi over 10. That looks a little better in my mind. So remember, I have found a bunch of values. I found b, I found c, I found a vertical shift downwards by 0.1 units. What is the amplitude? Well, what is half of the range? That's 1.9. So this is the amplitude. And clearly this one was not any reflection. And why it is not any reflection? Because at 0 you have the positive highest value. So what I say? I write my function as y equal to the a value, that's the shift, the amplitude, which is 1.9, positive with no reflection. It is a cosine function, so cosine times, now you do bx minus c. Well, b we found out to be 9 pi over 10x minus c is 0 because c we found to be 0, no phase shift. Then it has a shift down by 0.1 units, so minus 0.1. So essentially I can write y is equal to 1.9 cosine 9 pi over 10x minus 0.1, and that should be the final answer. Now what I will do now, I will start with the same graph, but instead of thinking it as a cosine function, I will think about it as a sine function. So what I do, remember, for a sine function now, I can think of this entire situation starting at this point 1.2. And this one is the value 0. Then the function goes downward, so there is a reflection along the x-axis. So I remind myself, reflection along x-axis. And remember, in this situation, if you think this graph as a sine graph, your center line is still 0, so there is no shift downwards anymore. Okay, the next 0 happens at this point, and the third 0 happens, which is one full period, at this point. And this point is 2.4. So first and foremost, this graph, instead of starting at 0, started at 1.2. So there is a phase shift. So I say phase shift is 1.2. Period, remember the full period, it started at 1.2 and it ended at 2.4. So it's 2.4 minus 1.2, and that should be equal to 1.2. I also know this is a reflection along the x-axis. So output should be positive, from positive to negative. Also, now you need to know the amplitude. Well, if this is your situation, if you have started at a 0, then you know that the top side, the highest value being 1.8, and the lowest value being -2, just by the work that we have produced earlier, one can easily say that this function also has a vertical shift of -0.1 units. Again, why I'm saying a negative shift of 0.1 units? Because the highest value is 1.8 and the lowest value is -2. So the same work as in the previous situation with the cosine function will give me a vertical shift. So let me write that too. Vertical shift of negative, or you actually can say 0.1 units downwards. That's a vertical shift of -0.1 units as well. Okay, so I need to find out the constants. One thing is pretty simple. It's A. Absolute value of A is still 1.9 units. So my A is actually going to be a negative. Why? Because it is a reflection along the x-axis, so it's a -1.9. B in this situation will be evaluated from the period. So 2 pi over B was the period, which is 1.2. That means B is equal to 2 pi over 1.2, which when simplified is pi over 0.6. And again, you can write it as 6 pi over 10 or 3 pi over 5. That is going to help you to find the C value. Remember, the phase shift is C over B. So in our situation, it is C over 3 pi over 5. And that I found out to be 1.2 as well, because the phase shift is 1.2. So that implies C is equal to 1.2 times 3 pi over 5. So 1.2 can be written as 12 over 10 times 3 pi over 5, which is equal to, well, I can easily divide both top and bottom by 2 and make it 6 times 3, 18 pi over 5 times 5, so 25. And I'm done, because now I should be able to write down the equation of the function. So So y, remember this time you were writing in terms of sine, reflection, so minus 1.9 times sine of b is, we found the b value for us is 3 pi over 5, so 3 pi over 5x minus c is 18 pi over 25, and then I have a shift of 0.1 units downwards. So that is your final form of the function. So the same graph can generate a sine function. It can also generate a cosine function depending on which way you want to write down the function. So that pretty much concludes our study of graphs of sine and cosine function. Next class, we will start talking about the graphs of tangent, cotangent, secant, and cosecant functions.